Welcome back to the Late Start Racing channel. Today we're working on Gramp's 944 Turbo Land Speed car.
And today's a big day because we're going to start making things permanent for the new VS Racing 7875 Turbo, and we're working on the up pipe to it, and we're gonna do some permanent welding, some back purge welding, and Gramp's been working hard this week.
Yeah, I got 3 days on it, got it all done, and decided to check the steering rod, and that's what this is right here, and found out it wasn't right, so I took it all apart and started over and just finished it last night at 5:30. All day on it, reconfiguring it. Just so many places you got to clear. So, yep. It's all tacked together. Forrest is going to weld it, and hopefully it doesn't pull and push too much and throw all my dimensions off.
Which happens.
Yeah.
Yeah, stainless moves. Stainless moves a lot. We're going to put a few more tacks on it before we take it out.
Yeah.
Yeah. So, we'll get to it. All right, so we're going to get started on getting this up pipe fully welded. We're going to tack it some more and stuff, but first I thought I might give you a walk around where the engine is out of the car and sitting on the bench. This is how we've done all the fabrication for the exhaust in the past. So last year we had a big go around, which is what I'm going to show you. So I'll bring you over on this side so we can start over here. So this header was all new last year. This is something that Gramp and I worked on for months on end to get finished up. Well, yeah, it's pretty much months. Yeah. So it's all schedule 40304 stainless Weldels, and I laser cut these flanges at the shop where I work, and just worked our way through building this all out. So it goes down to a 3-inch collector down below. And we've got the EGT bungs in every cylinder, so we're deadlogging the EGTs in here, which is good because we've had some pretty serious EGTs, which is part of the reason why we're doing this whole thing. Is just bigger is what we're doing, because we just have such just awful exhaust back pressure causing just a great deal of heat in the exhaust. So yeah, so this was all last year's project here, and then also down around to the up pipe, that's all new. We got the same wastegate, the 40mm tile on it. The 3.5-inch exhaust was all new last year also, because it had a 3-inch kind of modified aftermarket system that we just, Gramp made fit. Actually, I can get in here and you can see the spec clutches that's in there. So this is the original downpipe for the 6762 Turbo, and we just got it in here to mock up to look at what it's going to be like to connect the 7875 Turbo up. The turbo position is drastically different from the 6762 that was in there. The 7875 has moved way forward, so this whole up pipe system where it comes across to here is the same as it was before, but from here up is different because we're way forward now. Before, this pipe came right up almost parallel to the down pipe and then worked its way. You can see this custom motor mount that Gramp had built, and this was beat on here so it would fit up through and hit the turbo up in here. And now we're running reverse rotation mirror turbo to get the inlet to the the turbine, exhaust turbine housing out away from the block so that we could fit it up in there. But yeah, so this is what I'm going to be working on. I'm going to be tacking this up a little bit more before we take it out, because other than that, it may move a bunch. Stainless moves around a lot when you're welding it. But so this is the project for today, getting this guy in. So it's a lot, it's actually a really nice shot here to see, being able to see it in the car. You can't see it quite as well, but gives you an idea of the size of the turbo. The old one fit underneath here, or the last one fit underneath here really neatly. Something else you might notice is if you know about Porsche 944s, this cover right here is a little unique. Grant might explain that, but that's it already had a balance shaft delete in it, but we also deleted the original cover to give room for the last turbo to fit in here, and also modified it so we get our oil pressure port out through that plate, which is where it would have come from originally, but it would have been on a journal for the balance shaft right here. And of course, we've got our red, white, and boosted late start racing mini turbos. So those are available on the website, latestartracingteam.com. There are 3 different sizes of these. They're great for gifts for any gearhead, hanging on random things in the shop. Makes it kind of fun. The rear view mirror of your car, show everybody that you're an automotive enthusiast. You like turbos, you like boosts, you like going fast, and also red, white, and blue. It is America, right? So yeah, go ahead over to the website, check those out. They're a great gift too. All right, let's get into it. All right, so we're gonna go through and all right, so I'm gonna start getting we just had this this downpipe mocked up so we could see, just to give us an idea of where things should be in the steering shaft set up in here. So I'm gonna get that out so then I have some access to put some heavier tacks on this up pipe before we actually try to remove it and finish weld it. And I got to go get my gear on too. So we'll go ahead, just easy removal there. It's a quick removal on that. And then I'm going to leave the wastegate actually on there to plug up that hole, because we're going to be back purging this. We'll go to actually do the final welds. So we'll leave that on to just plug that hole. But we'll take the downpipe off anyways. And we'll set it aside. We'll grab the clamp and we'll put bolt back in it so we don't lose that. We don't want to be losing nuts and bolts now. Okay. So we got that stuff off. So welder, we got the it's a Lincoln Precision TIG 275. It's an older machine, capacitor machine. It's huge because it's not an inverter machine like newer machines would be. The smaller TIG welders are inverter machines, and they're just a lot smaller because it's smaller, efficient package. But nonetheless, this is what we have, 275 amps, but we'll use, I don't know, 60 today maybe. So DC negative, and of course running argon, and then where we've got the Weldmonger BBW cup on here. And actually that's something that is really something that you folks should consider if you're getting into doing this kind of fabrication and welding. The Weldmonger website and the Weldmonger products are pretty awesome. They put together these kits that are just fantastic. So if you're getting into TIG welding and you're going to do like a mixture of aluminum and stainless, I would recommend this gas lens kit right here. And inside, I don't know if I'll be able to tip it up so you can see it with that camera angle, but you've got gas lenses for your 1/8 inch, 3/32, and 1/16 tungstens. And you also have your cups for if you're doing aluminum, you've got your your number 6 and your number 8. And then if you're doing stainless steel like we're doing today, and you need a big cup because you have a reactive metal and you need to keep that gas coverage to keep it from the oxide happening, we've got all sorts of different sizes in those too. So it's a pretty fantastic kit for the money and everything that you get in it, and you don't have to piecemeal stuff together. So I would highly recommend this. So I'm going to go get my gear on and come back. All right, so we're going to get started tacking this up, but I just wanted, so I've got my gear on, so welding cap, most of you all have that. Something that I really like is these Lincoln Electric sleeves. So it's got a synthetic upper with a leather lower, and you can just pull them over anything. So if you wear a t-shirt all the time, or it's hot in your shop or whatever, but you need to cover your arms up because you're laying your arms on hot material, sharp edges or whatever while you're welding, these are awesome because you can just have a regular shirt on, throw these on, and have arm protection versus having a complete jacket on, which I have also. But sometimes it's just too warm. This is more comfortable when I'm just doing DC, you know, stainless TIG welding, whatever. It's not hot like aluminum, so you don't worried so much about the flash and everything on your body and the heat, the extra heat there. So it's actually more comfortable and more ambidextrous with just these on. Something else. So I am also going to be using my papper. So I have a Lincoln Electric papper unit. Obviously, this is not what most of you will have. I have this because I actually do weld on the side as another job. Doing Late Start Racing, the YouTube channel. I also do Late Start Fabrication, where I go and I weld for folks on top of my day job. So I want to preserve my health. So I wear a papper because when you're welding stainless, there's something called hexavalent chromium. So any metal that has chromium in it, when you're welding it, it goes off, it gets in the air. I won't go into the science on that, but it's extremely bad for you. So you need to prevent yourself from inhaling hexavalent chromium fumes. So you could get a papper, but so I actually got this used on eBay. I think it was like $850 for this. So it's got a backpack unit. I don't know if you can see that, but it pulls in fresh air through carbon filter on my back and then pumps fresh air into the hood. But you don't need to have this. You could get something less expensive. So before I got the papper, what I got was just a 3M. I prefer these 3M ones. You can get something else. The key thing is if you're going to wear a respirator, is that your filters, which these are NIH P100s, and if I remember right, these are good for, because I did check, or if I remember right, these were good for welding fumes. They're rated for that. The key thing is the low profile, so it fits under your hood when you put it on, because if you have the bigger ones, your hood won't go down over them. So these are kind of nice because of that, and I like the 3M ones. I've worn these. This is the same face mask or face piece that I've used for painting for many, many years. So this is super comfortable. So you don't need a papper, but you do need something. So you can use this under your helmet, and you can also use a localized ventilation system. So a weld fume sucking unit. I don't really know what they're called. An exhaust hood. You can use one of those as long as you keep it close enough that none of the fumes get to your face when welding stainless is super key. And if you're just tacking and everything, I'm sure it's not going to give you any long-term problems. But if you weld enough stainless, it will potentially give you some health issues later on. And why bother do that? We want to keep racing for a long time. So. All right, so now I've got this set up. We're going to go in and we're going to do some more tacking on this just to make sure, like I said, it's strong enough that we take out. It doesn't just move just because we didn't put in any extra effort to get the tacks strong enough. All right, so I've got the mic on the side of my hood, which hopefully you can still hear me. We're going to use some 308 45 thousandths filler wire just to make sure that we don't create any holes here, because I don't have any gas back purging this right now. So when I'm doing that, I want to make sure that my tacks don't penetrate to the other side to allow the ambient air on the backside to get to the weld and create what's called carbide precipitates, which is that nasty, super hard gray junk that forms on the inside or the backside of a stainless weld that hasn't been back purged. And we especially don't want that in our up pipe, because next stop, if any of that stuff breaks off, next stop is our exhaust turbine and our exhaust turbine wheel. And we don't want super hard carbide precipitates to go through the wheel and damage it. The other thing is too, is it makes the weld is not as strong as if it were back purged, if it has that carbide precipitate, because the weld doesn't actually penetrate all the way through the material. So we're going to try to avoid that. I'm going to guess and say that in some of these tacks, when Gramp was putting this together, there might be a little bit in some of these places, but we're going to avoid as much as possible, and we'll go in there and clean up what we can if there is any. They all look pretty good, so I'm guessing we're not going to really have that issue. But all right, so we'll get into putting some more tacks on this. I'm just going to go around and add basically 2 more to each joint, and I'll try to get you in there so you can see it. Maybe I'll flip you around so you can see some of it. Help if it were grounded. There we go. So we always leave our gas coverage over our weld until it cools down. I got the post flow set, I think the 15 or 20 seconds, I can't remember. Let's see. Post flow set to 20 seconds. A small weld like that, you might not need that long, but it doesn't hurt. It just costs a little bit more gas, and you just know that you're not going to have an issue. All right, so we got tacked up a bit more. I think it's enough that we take it off and take a look at it, and we'll weld probably these couple of joints down here first. We'll fully weld those, and then we'll put it back on and double check that everything still fits. And before we go and weld anything else, to make sure we don't get too far ahead of ourselves and end up with it turning into a noodle, which it can. It's a lot of joints here, and from over there all the way to up here, shrinkage can do a lot to make this not go well. All right, we'll get it off and then we'll get back to it. All right, so hopefully you can hear me over the heat, which is coming from like right over there. It blows right down across the bench here, so you're nice and toasty while you're working at the bench. But anyway, so we got the up pipe off, got it on the bench here, and got it set up so it is purging right now. So just use, you can buy silicone plugs that go in here and have ports in them. Those are really awesome. I have some of those at my day job, but haven't bought any for here at the shop. Is what it is. We use aluminum foil. Get use some some decent aluminum foil, not super thin stuff. Use the thicker stuff. It holds better on the joint. So I've got all the holes plugged. I've got the wastegate on the wastegate port, and then this would be off from the header, and then this would be the turbo side. So I've got those crunched up. We have our exhaust pressure port down here anyways, so I'm using that and feeding argon into the pipe with this 1/4 inch line with a push to connect fitting. And then on this foil up here, I just popped a little hole in it honestly, there's enough gap in in these joints around that we're leaking argon anyways. But the point is that you put it argon in, it's heavier than air. You put it in at the low point and you let it fill to the high point, and then you have an opening at the high point to let it out. So that'll push all of the ambient or atmosphere out of the pipe, so that it can be fully purged and inert the inside, so that when we're doing our welds and we have enough energy in the weld, that when we light it up and it gets golden, white, yellow, hot, you don't form the carbide precipitates on the backside from oxide in the air, or from it oxiding in the air. It'll be inerted on the back, and it should, if everything goes right, the inside of the weld should look almost as good as the outside. I've never had it look exactly the same, but it should be the same, at best, bluish hue on the inside, and then you've got a good back purge weld. So we're going to let this set for a bit, and we'll make sure we get all the atmosphere out of it before we start welding on it. And we're going to start, like I said, on these two lower joints here, get those nice and firmed up, and I'll flip it all around. It's going to be like a monkey, going around flipping this all over until I get this welded, and then we'll check it back in the car. Alright, so it's been about 10 minutes. I think we're probably good enough. I'm going to start welding on these two, and we'll get going. I'm having an awful time with getting the right gas coverage or something, or tungsten or something. So it's just not going exactly how it should. So I'm gonna pause, and I'm going to look at everything and make sure I haven't missed and figure this out before I keep going. Because the worst thing is, whenever you're having trouble with something like this welding, don't just keep going. Pause, take a minute, and try to figure it out. The regulator setup that we have in order to do the back purging is a little rigged. I actually don't have a flow valve on the torch. For the torch side, I'm going by sound. But this size cup is pretty finicky about how much gas flow it needs. You got to be running like I think it was like 30 CFH on that cup or better in order to have good coverage. And I'm having good coverage, but then the next second I'm not. So I think I'm gonna pause. I'm gonna clean everything. I'm gonna double check a bunch of stuff. Check my tungsten. Maybe try a fresh tungsten. That one's been used quite a bit. I did just sharpen it, but I'm just gonna go through and make sure everything's nice and clean and get started again. All right, so I went back through and I cleaned everything again. I went back through and I brake clean acetone all the outside of the pipe again. I went and I stainless steel wire brushed every weld area. We have a stainless steel wire brush on a pedestal grinder. Went around it, and you can see probably some of these spots here. I don't know if you can see that from there, but you can tell where that's been done because it looks duller. Went back through, did that, prepped a couple of new tungstens, cleaned that all up, checked all my gas pressures and everything. I did up the gas flow to the cup a little bit more. And just for giggles, I upped the gas flow through the pipe because I usually started at 15 CFH and then after about 10-15 minutes, depending on how big the pipe is. I'll turn it down to 5 just to conserve a little bit of gas, because once it's full, my thought is, I could be wrong, it's not really going anywhere at a great deal of speed once you've filled the volume up. And things went a heck of a lot better. So I got some pretty clean looking welds over here. They're not my best, that's for sure. But there's some, some used pipe here, some new pipe, and all of it doesn't quite match up in diameter. They're all from different places, and some of this stuff has been on a few different things because we use what we have and buy, like, here's a new piece right here, but everything else was stuff that was new material but been around the shop for a little bit from building a few different things, and other pieces are, original pieces. So I actually decided, so I finished those 2 welds there, and I decided these 2 welds here are really good fit up. They're really tight. So usually when they're that tight, they don't move that much when you weld them. They still do, but so I'm going to weld these 2 while I've got it purged already. This one over here is not, that one is not the best fit, and that's the one that's going to move the most. So I'm going to weld these 2. We'll fit it back on the car, and of all the welds that will have to be cut loose and and fixed again, it'll be that one down there. It'll be this one on the corner. That's the one that will need to be fixed. So I'll go through, weld this stuff up real good, and then leave just that one as our one to move, because since we got V-bands, we can rotate stuff and kind of get stuff home. We can, knock it in and we'll go. So I'm going to go ahead and finish welding this stuff out, and you can watch. All right, so we got these 2 welds down here done, these 2 welds up here done. We still have this weld left, and these 2 welds left here. And I put it back on because, like I've been saying, this stuff just moves around. This is a pretty long pipe. It's got quite a bit of leverage from all the way over here. If we look back from here all the way up around, so just a little bit of movement in this weld here, shrinking as it cools, just a degree makes a huge difference in where that point up there ends up. So we put it back on, and as you can probably see, there's the gap in here. Let's see if I can get a little more light on it. There we go. There's the gap in there. So what I'm going to do is I'm going to cut this loose, and I'm going to finish weld this joint right here. I'm going to finish weld that, mock it back up, or sorry, whoops, got the steering move out of the way. We had to check the steering clearance. It is a little bit better than that. So it's just barely, and then the edge of the frame rails right here. So we're going to finish weld this. We're going to finish weld that guy there, and then cut this loose, and we'll put it back on, put the clamp on here, and then tack this guy again. And then at that point, everything should still work. If it doesn't, we'll have to cut it. We'll have to make some, I'm going to knock that over. We're going to make some choice cuts in places and get it to work right. But this is a really good spot for the turbo. We got good clearance here. We're level. Our inlet to the compressor is probably just above the frame rail here for the filter that comes down over. Actually, I can probably show you that real quick. So the inlet of the turbo goes right over the top, and then the air filter is down inside here, which makes it really convenient. So if we're up above that, and this is the spot right here that up pipe is trying to miss, where the steering comes down through here, the pipe goes through there. So that's what we got to miss. So we can always dent this in if we have to, but we shouldn't. There should be plenty of room in there. So I'm going to take this back off, finish welding those bits out, and then I'll get back to you. All right, so I've got this weld finish and this weld finished, and I've got it put back in. Oh, and I got to buff you out. There's that better? Does that look better? I don't know, about the same. Okay, so got this weld finish, that weld finish. It moved a bunch again, but what I ended up doing, I'll bring you in here so you can see it. So I got this guy welded up. The gap that was on this, of course, closed up, even though I had a tack holding it from closing. It's stainless is some fun stuff. I really enjoy it. It's kind of like, oh, did you see that? Yeah, right there. So there was a gap over here, and it closed up as I welded it, even though I had a tack on the backside holding it open, but it's still closed up, but whatever. We're here. We still got steering clearance. We still got the clearance we wanted here. We come around, we still have the clearance here and here that we were looking for. So that's good. And then I went in, this doesn't have the color on it because I've done the stainless wire on this section here, because I cut the V-band unit loose because that didn't line up at all. That was way off. So I cut that loose, welded these two good, cut it loose. So now it's found a home and it's stabbed on there. Now, one thing I'm gonna throw myself under the bus here. That piece of pipe is not like way up in that V-band. There's actually, you might be able to see it. There is just, it's just barely on right in there. I don't know if you're going to be able to see that. It's just in there. So there's going to be a weld like right on the edge. Because there's so much heat at this joint, I would really prefer that this piece of pipe was fully engaged in that band. But I am pretty comfortable welding it where it is, because the way the joint is, it's already got a weld right here. It's a pretty stiff area as it is. But I just worry about heat. You know, there's a lot of heat right here, and a lot of that heat cycling, that temperature cycling. So you worry about stuff cracking without being held very good. But I'm gonna make sure I've got a really nice clean weld on that, and I'll weld the inside also, and that should be pretty good. Usually I have it shoved all the way up in there, so it's just down from the top lip, and then I weld the inside and the outside, and it is what it is. So anyways, that's what I'm gonna do next. I'm gonna tack this up, take it off, fully weld it, and then fit it one last time, hopefully one last time, but you know, stuff happens. All right, we'll look at it after and see how good it came out. Look great.
Get out of here.
I don't have a mic on. I don't have a mic on.
You don't. All right. So, there's a thing.
Use this one.
What?
There's a thing, right, Grant?
Here's a thing.
Here's a thing.
Yeah, that's the
It's got some
biggest.
pink.
That's the biggest obstacle I think at this point for me on this job is that one piece of pipe right there.
We got it all
Because
welded up in here. Whoops, we got to turn it on light. Here we go.
Yeah, I'm going to go over it too.
Ooh, look at that. You can see.
Yeah, everything's kind of close.
That's all welded. Yeah, it's.
You could do it right on this.
close
You could
in
do it on this
there.
video first.
Kind of close in there.
About this part right here.
I've done that.
Oh, you got this on video?
Yeah, it's videoing right now, so it's going to be. On
Oh,
there.
that's what I mean. Yeah.
Yeah, I
Having
did.
to deal with this,
Yeah, no, I did do that.
locking
earlier.
this up and everything. Sure.
Yeah. So that is actually like somewhere right there, I think.
But yeah, 7 inches.
So it's a little close right there.
But we can deal with that.
It's a little close. I don't know if we can get the right angle. Probably better.
Yeah, down in
A little
here.
close down in there.
But that's as good as it was before.
But you got this whole thing, which is like a big heater anyways on the back of the oil pan. So for that to be a little tight in there, as long as it doesn't touch,
once it's wrapped,
it's not a big deal.
And if you stop and think about it, this exhaust and the bigger hot end on the turbo, getting rid of the air,
it shouldn't be as hot.
We should lower the temperatures through that exhaust.
The whole thing should be cooler.
Yeah.
And you still got space.
Yeah, that came out really nice up there. I'm really happy with that clearance.
Yeah.
You know, where you gain one place, you're going to lose in others.
Yeah.
But here, no matter what we did up here, this right here was, I mean, between the unitizer, the frame rail, the car being right here, and the steering having to be right here, nothing we could do with this. Right. I mean, you could have a brainstorm and come up over the top, then you wouldn't get this pipe in at all.
No, this is way better than it was last year, too. Yeah.
And once I wrap that, I think it'll be fine.
Yeah, it's going to be fine.
Yeah, with the motor mount down, and I was a little concerned about that, but it's out this way. And there's going to be plenty of air coming through here.
Air, yeah.
Plenty of air. And the rubber it's down in a pocket.
I might have to build our own motor mount someday.
They make steel ones. You can get rid of that rubber altogether.
We can make our own steel ones too. Aluminum or whatever.
I don't know if the heat would bother that or not.
We're gonna find out.
Yep.
We're gonna find out if it melts, if that gets too hot.
The way I look at it, we're on the road this summer to 180 miles an hour.
180. All right, 180. That's the prediction. What do you think, Berkey?
I'm gonna say what you got. 170.
We had 167.
167.
It says 169 when you watch the speedometer.
Yeah, it does.
It's off a little bit.
I'm gonna probably say 176.
176.
176.
We're only gonna make
9
mile an hour.
I'm gonna hope for the least. Just so maybe we can get excited.
For the least. Oh,
so you can get excited, you know.
I know. Remember last time we
under
tried to
promise
guess
and over deliver?
It was way over what we thought it would be. Do you know that from last year to from 2022 to 2023, 2022 was 154, 155, and we're at 167.
Yep.
So you're 12 miles an hour up. Yep. In 1 year.
But it doesn't mean it's going to do it again.
The turbo that 67 62 made a bit of a difference. So,
but not like this is going to.
Hopefully this feller here will make that.
Imagine it goes like.
So we went from 275 to 375 horse.
Yeah.
Basically wheel, so 100 horse. So if we go from 375 to 475 this year,
I think we'll be well into the 400s. I think.
Primo.
And like I say, after taking the engine up, I was happy with that. So the condition and everything.
All right. So you'll probably see Grant next doing some more stuff here. So we'll get on to that.
Yep. We'll see you next time.
Bye.